Exercise 7.2 problem 17 discussion. So let's read the problem. From the top and the foot of a 40-meter high tower, the angles of elevation of a top of a lighthouse are found to be 30 degrees and 60 degrees respectively. Find the height of the lighthouse. Also, find the distance of the top of the lighthouse from the foot of the tower. So basically there is a high tower, there is a tower and there is a lighthouse, right? You are looking at the top of the lighthouse from the top and the bottom of the tower, and the angle of elevation is 30 degrees and 60 degrees. The height of the tower is 40 meters. We are asked to find the height of the lighthouse and the distance of the top of the lighthouse from the foot of the tower. It's quite a different problem. Let's draw a simple diagram. So here AE is the tower, okay, then BD is the lighthouse, right? Now what do you need to do? Mark this height to be 40 meters. This is given from the foot of the tower, okay, from the foot and the top of the tower you are observing the top of the lighthouse. Am I right? Please, okay, please check it out here. See here it says from the top and the foot of the 40-meter high tower, the angle of elevation of the top of the lighthouse. Am I right? So from here and from here, you are observing the top of the lighthouse and the angle of elevation is 60 degrees and 30 degrees. How do you draw the angle of elevation? Draw a horizontal line which is eye level, okay, and draw another line which is connecting the point to the that's a line of vision basically. Okay, this is from here you are viewing point D. So join this line, and this is the eye level. So the angle between those two is the angle of elevation. Similarly, it is here 60 degrees. Now we are asked to find the height of the lighthouse. We are asked to find the height of the lighthouse, and we are also asked to find the distance from of the top of the lighthouse from the foot of the tower. This is the foot of the tower, right? So this distance AD also we are asked to calculate. So we need to calculate BD, which is the height of the tower, and AD, which is the distance between the top of the lighthouse from the foot of the tower. So these two AD and BD we need to calculate. Okay, so very simple. This is 40 meters, so which means this is also 40 meters, and EC is equal to AB. Use tan 30. Tan 30 is CD divided by EC. So from that calculate EC. Tan 60 is BD divided by AB. From that calculate AB. But we know AB equal to EC. Equate those two equations. You will get a relationship between CD and BD. Then another relationship is BC plus CD equal to BD. Right? But what is BC? BC is 40 meters. So 40 meters plus CD will be equal to BD. Using these two equations, you will be able to get the value of lighthouse, the height of the lighthouse, BD. Then you want to know this distance, right? What is this distance? You want to know this distance, and you know this because you know the height of the lighthouse now. So what is the relationship between this side and this side and this angle? That is sine 60. Sine 60 is opposite by hypotenuse. Using sine 60, you should be able to calculate AD. Okay, so this is how this problem needs to be solved. So let's work it out. What is given? Height of the tower is given. The angle of elevations are given. Right, height of the tower is 40 meters and the angle of elevation is 30 degrees and 60 degrees. What do we need to calculate? Height of the lighthouse we need to calculate, which is BD here. Am I right? B and D. Right? Next. What is the formula? Tan theta equal to opposite by adjacent and sin theta equal to opposite by hypotenuse. So in all these cases, we have to relate this to this. So that is always tan theta. But in this specific case, we also need to find this length, that is AD, which is nothing but hypotenuse of this triangle A, B and D. So that is why we have to use sin theta here. Right. What's the step? Draw a rough diagram. label and mark the diagram with given values. In triangle DCE, and E, substitute the value of theta. Theta is 30 degrees. So tan theta is opposite by adjacent, that is CD by CE, and calculate CE. So tan 30 is CD by CE. So you get CE in terms of CD from that equation. So let's put that as equation 1. In triangle ABD, this triangle, tan 60 is opposite by adjacent. Opposite is BD divided by AB, right? So again, you can, so using that in this equation, this is known and this is known. Oh, sorry, this we also know. But using this relation, we will get AB in terms of BD. You will get another equation. But you know, AB we just calculated in equation 2 and CE we calculated here in this equation 1 are both the same, right? CE equal to AB. So equate the RHS of both the equations. You will get a relationship between CD and BD. Get that? Okay. So you will get a relationship. Next, there is one more relationship. You see, BC plus CD equal to BD. Am I right? So, and we know BC is 40 meters because AE and BC are equal. So, using that, you will get one more relationship. So, solving these two equations, we should be able to get the value of BD, right, which is the height of the tower. Then, go to triangle A, B and D. And what is sine 60? Sine 60 is opposite, that is the height of the lighthouse, divided by hypotenuse, which is the distance between the foot of the tower to the top of the lighthouse. So, in this case, sine 60. So, sine 60 we know, BD we just calculated in the previous step. So, this is also known. So, which means AD can be calculated from this equation. Okay. So, this is how this problem needs to be worked. Now, what I suggest is you pause the video here and try to work this problem on your own, and on completion, please come back and check your working against our solution. Okay, solution. So, let AE and BD represent the tower and the lighthouse respectively. So, what is AE? This is the tower and BD is the lighthouse. So, from the bottom and the top of the tower, you are observing the top of the lighthouse. So, join these lines and you get the angle of elevation 30 degrees and 60 degrees. Now, consider this triangle DCE. Tan 30 is opposite DC by CE. So, come here, tan 30 equal to CD or DC, it's all the same, divided by CE. And what is tan 30 is 1 by root 3. So, CD by CE equal to 1 by root 3 or CE equal to CD root 3. Okay. So, this is one relationship we got. What is it? CE equal to root 3 into CD. 1.732 times of CD. Okay. So, you have one relationship. Now, go to this triangle A, B and D. What is tan 60? Tan 60 is opposite. That is BD divided by AB. Right. That's what we got here. Now, what is BD by AB? BD by AB equal to root 3. Tan 60 is root 3. Right? Now, which means AB will be equal to BD by root 3. And you don't want to have root 3 in the bottom. So, you multiply the numerator and denominator by root 3. It becomes root 3 BD divided by 3. So, AB equal to root 3 BD by 3. But from the figure, we know AB equal to EC. Am I right? So, what happens? So, then, so AB, so which means right hand side of equation 1 and equation 2. See equation 1 for your reference I have written here. CE equal to root 3 CD. But we know CE is also equal to AB. So, which means this is equal to this. So, root 3 CD equal to root 3 BD by 3. So, root 3 and root 3 will get cancelled. Right. So, 3 CD will be equal to BD. So, this is one equation. Now, next equation is, you see this one, that is BC plus CD will be equal to BD. Am I right? So, that is what we have written here. So BD is equal to BC plus CD. And BC is equal to 40 meters. So substitute that. So 3C, and this is one relationship. Now in this, we know BD equal to 3CD. So substitute that here. So we'll get 3CD equal to BC is 40 and plus CD. So which means 2CD will become 40 and CD equal to 20 meters. And if CD is 20 meters, you know BD is 3 times CD. So BD is 3 into 20, that is equal to 60 meters. Right, now in the triangle, so now we know the height of the lighthouse. The problem is done. Right, now in the triangle ABD, that is A, B and D, sine 60 is opposite by hypotenuse. Okay, so sine 60 is opposite, which is BD divided by AD, which means sine 60, this BD is, we just calculated it as 60 meters. So 60 divided by AD equal to the value of sine 60. Sine 60 is root 3 by 2. So, or AD will be equal to 120 by root 3. Right? And this again, we don't want to have root 3 in the bottom. So you multiply and divide by root 3. So this will become 3. So you'll get 120 root 3 by 3. 3 will go 120 40 times. So this distance is 40 root 3. Which means the distance from the foot of the tower to the top of the lighthouse is 40 root 3 meters. You got it? So height of the lighthouse is 60 meters and the top of the lighthouse is 40 root 3 from the foot of the tower. Okay? So I hope I made it clear. If not, please go through one more time. It will become clear. Thanks for watching this video.